Hello and welcome to our last lesson of the chapter, which is 4.4 Part 2, General Solutions of Trigonometric Equations. Before we start actually solving these things, we're going to just take a look at the graphs of sine, cosine, and tangent very quickly here. Now, you don't need to know these for this chapter. This is just so you can see how they repeat themselves. And you'll have an entire chapter on these graphs that come next, which is chapter 5. So you do not need to know these graphs for your test. This is just to help you understand how the solutions to the general equations work. So trig functions are called periodic. They repeat themselves on a given period. Okay? Sine and cosine repeat themselves every 2 pi or 360 degrees, meaning once you've worked your way around that quadrant system once, then they repeat themselves every time you go around that circle. Okay? Tangent actually repeats itself every pi or every 180 degrees. So once you've gone around the quadrant system halfway, then it starts to repeat itself again. Okay? Now we know that sine is opposite over hypotenuse or y over r. Okay? So if I'm looking, I can see there's some dots here. This is actually going to help us guide our graph here. So we're going to be graphing sine theta on the y-axis, and theta is on the x-axis. So our input is theta, our output is the function sine theta. Okay? And the maximum we talked about yesterday that sine theta can be is 1. Right? That's the biggest answer we can have for a ratio here. And the smallest is actually -1. Okay. Now we also know that we have in our quadrant system, we know that sine is positive in the first quadrant and the second quadrant. We know it is negative in the bottom 2 quadrants. We know that on the initial axis, the positive x-axis, it's equal to 0. We know that on the positive y-axis, it's equal to 1. On the negative x-axis, it's equal to 0 again. And on the negative y-axis, it's equal to -1. So if I take a look at how these dots lie, you will see that it starts to increase. It's positive, it's positive, it's positive. Then it equals 1. It's still positive, but it's heading back down towards 0. It's equal to 0. It heads down in the negative direction here, and then it's equal to -1. It stays in the negative direction, but it ends back up at 0. Okay, so we can see it's positive here, and then it's equal to 1. This happens at pi over 2, or the positive y-axis. It's still positive, but it heads back down to 0. It's 0 at the negative x-axis, which is pi. It's negative down to -1. It's -1 at the negative y-axis, which is 3 pi over 2. And then when it has completed a full cycle, it reaches back to 0 again at 2 pi. And then it repeats itself. It does this for another cycle. Okay. For our second cycle, this would end up at being 4 pi. It would cross in the middle at 3 pi. And we will be more detailed with how these are developed when we do the next chapter. We can also do a negative rotation of our circle. We don't always have to be going in the positive direction. If I go in the negative direction, I would be heading back this way. And this would be at negative pi over 2, negative pi, etc. Okay. So we can see that as it goes up, it's positive, comes back down towards 0, then goes negative, comes back up towards 0. So up, it's positive, goes back down towards 0, goes negative, negative back up towards 0 again. Okay, so it takes a rotation of 2 pi before it repeats itself. We can follow something similar for cosine. So we know cosine is adjacent over hypotenuse, which was x over r. And if we think about the quadrant system for this, we know that cosine is positive in quadrant 1 and 4, negative in quadrant 2 and 3. We know it equals 1 on the positive x-axis, -1 on the negative x-axis. Okay, so y-axis 0. Now, when we draw our graph, again, we know the maximum is 1, the minimum would be -1, and it's going to take us a full circle before we get back to the beginning. If we take a look at this graph, at our circle here, we know that we start at a value of 1, we're positive, but we approach 0. Then we go negative down to -1. We're still negative, but we're heading back up to 0. Then we're positive, heading back up to 1, and we're back at the beginning. So we start at 1, we're positive, but we're heading down towards 0. So we're 0 at pi over 2. Then we're negative, heading down towards -1. That -1 value happens at pi. Then we're negative, but we're heading back up to 0. That happens at 3 pi over 2. Then we're positive, heading back up to 1 again, and that 1 value happens after we've completed a full circle. Then we would do this cycle again. By the time we've completed another cycle, we'd be at 4 pi, 2 circles. We could also head in the backwards direction. Okay. And this negative value would happen at negative pi, and this would be negative pi over 2. Okay. Again, our period here is 2 pi, meaning it takes 2 pi to complete an entire cycle. This graph was theta on our x-axis and cosine theta on our y-axis. Last one is tangent. Okay, we know that tangent is opposite over adjacent, which would be y over x. Okay. Now for our tangent, okay, we know that tangent is positive in quadrant 1 and 3, negative in 2 and 4. We know that it equals 0 on the x-axis, and it does not exist on the y-axis. Now, if we think about this, this makes sense. If y is 0, it doesn't matter what x is, our fraction would be equal to 0, right? 0 over anything is going to equal 0. That would be happening on the x-axis. If x is 0, doesn't matter what y is, that would not exist. That's why we have a does not exist on our y-axis. On the y-axis, x is 0. Okay. So what this actually ends up looking like is we actually have asymptotes at pi over 2, which would be the positive y-axis, and 3 pi over 2, which would be the negative y-axis. So this actually has asymptotes on this graph. So this one's at pi over 2, 3 pi over 2. Then if we keep going, we get 5 pi over 2 and 7 pi over 2. We know that tangent is 0 on the x-axis, which would be 0, pi, 2 pi, etc. So 0, pi, 2 pi, 3 pi, 4 pi. Okay. And we know that if we're looking at this first one here, we know that at 0, it's 0. But then when we go in the forward direction, we have positive values. And if we were to go in the backward direction, we'd have negative values. Then when we get to the other side of our does not exist over here, we have negative values. And then we hit 0, and then we have positive values. And then this will keep repeating itself. Okay. So again, here the period is pi. It repeats itself every pi. So let's try some questions. Okay. So if we want to solve sine theta equals -1 for all real solutions, okay, so we know that sine theta is equal to -1 on the negative axis, which is at 3 pi over 2, right? Now, the problem is that if we were to go forever for all real solutions, this means that if I do another circle, I'll end up back here, and another circle, and another circle, and another circle, and I could keep going forever. I could also go in a negative direction and end up back here. So if I just had one solution, I would have 3 pi over 2. But I could also add an entire circle, which is 2 pi. Now I can add as many entire circles as I would like, which would be 2 pi n. Okay. but n needs to be an integer. I must add entire circles in either the forward direction or the backwards direction. So we're going to write n is an integer, okay? Or you can write n is an integer with your. So you can see, hopefully this looks familiar from when we did coterminal angles, okay? So we found the first one, and essentially we're finding all the coterminal angles to that angle that we solved for. So let's try one more. So if tan theta equals 0 for all real solutions, I know that tan theta is 0 here, okay? And this is either 0 or 2 pi. It's also here at pi. Now tan theta, that means that theta would equal to, we could say theta equals 0, or we could say theta equals pi, or we can say theta equals 2 pi. Keep going. But to get a equivalent angle for tangent, we don't have to add a whole circle. We only have to add a half circle. So I would probably pick this one. This is the easiest one. 0 plus a half circle would be pi, and I can add as many of these as I want as long as it's an entire half circle. So n would need to be an integer. I don't necessarily need to write 0 plus, right? 0 plus anything is just the stuff. So pi n would be my most simple answer. Now, technically, you could write 0 plus 2 pi n as one option and pi plus 2 pi n as another option and have two separate angles, one for here and one for here, but that would not be considered the most simple form of an answer you could give. So we will try something a little more complicated on the next side. Those would be very straightforward questions that you could receive. All right, so solve over the set of real numbers. So first, secant 2 theta equals 2 in radians, okay? This means that cosine 2 theta would equal to 1 over 2. It's the reciprocal. Now I'm going to say let x equal 2 theta, and I'm going to change this to be cosine x equals 1 over 2. I'm going to start with that, okay? Anytime you see a 2 theta, 3 theta, 4 theta inside your ratio, I would change it to something more simple and start by solving the simple thing you know how to solve. So when I do this, I know that cosine is positive in quadrant 1 and quadrant 4. I know that cosine is adjacent over hypotenuse. My adjacent is 1, my hypotenuse is 2. I know I have a special triangle that's 1, 2, root 3, so my other side must be root 3. On the bottom triangle, that must be a negative root 3. And my reference angle, therefore, would be pi over 3, okay, or 60 degrees. It tells me in radians, so I should be looking at pi over 3. So in quadrant 1, my first answer would be pi over 3. Now, as a general solution, I know that I need to add 2 pi n. Okay. My second answer in quadrant 4 would be 2 pi minus pi over 3, which is 5 pi over 3. And to make it a general solution, I would have plus 2 pi n. Now, the problem is in the question, we were not given an x, we had a 2 theta. So if x1 is equal to pi over 3 plus 2 pi n, that means 2 times one of my thetas is pi over 3 plus 2 pi n. Now I need to solve for theta because I'm not being asked what is 2 theta. I'm being asked to solve, which means I need theta. I need to divide by 2, which would give me theta 1 equals pi over 6 plus pi n. If I divide everything by 2, and then I need to include that n is an integer. For my second answer, I have 5 pi over 3 plus 2 pi n. This would be 2 times my second angle is equal to 5 pi over 3 plus 2 pi n. If I divide everything by 2, I get 5 pi over 6 plus pi n. N is an integer. So anytime you substitute at the beginning to make the question easier for you, you must remember to substitute back in order to finish the question. You are not done till you've substituted back in. Now it's up to you if you would like to try the other two on your own or if you'd like to continue on with me. If you'd like to try them on your own, feel free to pause here and skip through to your answers. Otherwise, you can keep going. So this next one, I'm going to say let tan theta equal x to make myself deal with this quadratic a little bit easier. So this would be x squared plus 5x plus 4 equals 0, or x squared plus 4x plus 1 equals 0, x equals -4 or -1. Okay, this means either tan theta equals -4 or tan theta equals -1. Now remember, cosine and sine cannot be bigger than 1 or smaller than -1, but tangent can be. So I'm going to have two separate diagrams, two separate sets of answers. Tangent is negative in quadrant 2 and quadrant 4. Now, if we have quadrant 2 and quadrant 4, okay, so for the first one, tangent is opposite over adjacent, right? Now, this is clearly not a special triangle, so opposite would be 4, adjacent -1, opposite 4, adjacent 1, okay? So for this one, I would need to use my calculator. Now it says in radians, so I know tan theta is equal to -4. So theta is going to be the inverse tangent of -4. If I use just 4, I can get my reference angle right away. Let me erase again. Okay. So my reference angle using radians would be 1.33. Okay. So I need to be in radians mode here. Okay. Oh, not liking this. Okay, sorry, I had to pause and just restart this Word file here. So it might look slightly different than you just had on your screen, but we know that our reference angle is 1.33 radians. Now we also know, which we can tell even by looking at our picture, that if I do my 1.33 radians, that would be this distance in here or this distance in here, our reference angle. But I can also tell that if I were to go between these two terminal arms, the difference between these two is 180 degrees or pi radians. So I don't actually need to find both these quadrants for tangent. I can just find one of these angles and write plus pi n. Okay. So if my reference angle is 1.33, I'm going to use quadrant 2. I know that theta is going to be pi minus my reference angle, which would be pi minus 1.33, which gives me 1.81 radians. So our general solution is theta equals 1.81 radians plus pi n, where n is an integer. That will be our answer for our first solution where tan theta is equal to -4. If I add a half a circle, I would get to the quadrant 4 angle. For the next one where tan theta is equal to -1, I know that I have special triangles where we have ones. If tan theta is equal to 1, we have opposite over adjacent. That means they both need to be 1. And in this case, we have a couple negatives in here because of negative x's and y's. Again, I know I have a triangle that's a 1, 1, root 2. And our reference angle for that would be pi over 4. Again, I don't need both quadrants. So I'm going to just use our quadrant 2 angle, where theta would be pi minus pi over 4, which is 3 pi over 4. If I add 180 degrees to that, I would get to the quadrant 4 angle. So theta would be 3 pi over 4 plus pi n, where n is an integer. Now, if you didn't do this and you accidentally found two angles for each of these, you might have not only a theta 1 and a theta 2, you might have a theta 3 and a theta 4. That's okay. It's more work than is necessary for tangent, and you might have accidentally written plus 2 pi n to each of those, which technically, if you were on, say, this quadrant here and you did a full circle and another full circle, that would be fine as long as you included a separate answer for this and did your full circles to there as well. Again, it's a more complex solution that's not needed. You can write this as one solution. And last one, we've got tan 3 theta is equal to -1. So I would say let 3 theta equal x, and I would write this as tan x equals -1. Now we just used a -1 version, and this was quadrant 2 and quadrant 4. Tangent is opposite over adjacent, which means they must both be the same number or both be 1. Okay. And our hypotenuse, therefore, would be √2. Our reference angle would be pi over 4. Okay. Now, again, with tangent, our period is pi, so I don't need both of these. To get from one to the other, I would simply add pi. So our actual angle itself, if I did Q2, our angle is equal to pi minus pi over 4, which is 3 pi over 4 plus pi n. Sorry, I should be using x here, okay, where n is an integer. Now, we originally had a 3 theta in the question, so we're going to replace this with 3 theta. Come on. There we go. Okay. And we want theta, not 3 theta, so I need to divide everything by 3. When I do that, I get 3 pi over 12 plus pi over 3n, where n is an integer, or pi over 4 plus pi over 3n, where n is an integer. So we need to remember this step here where we put our 3 theta back. That is it for this section and for the chapter.